Hi friends, first of all accept our kind apologies for being a bit late today on this real-time broadcast with Machine Maker. We are at Shree Rapid Technologies. Actually I was amazed by some of the 3D printed materials which is displayed here. You can see a lot of visitors are there who are looking at the different additive manufacturing printed products, 3D printed products available here. Shree Rapid Technologies is having a complete range of additive manufacturing solutions. Apart from that, they are also having a machine tool division where they offer certain metrology solutions. We will be discussing about that today in this real-time broadcast we are conducting today with Shree Rapid Technologies. You can see a nice bike here. We will see that why this bike is doing it here on our later time. So let's go and meet Sri Nitin Chaudhari, who is the managing partner of Shree Rapid Technologies. Hello, sir.
Hello.
Welcome to the real-time broadcast with Machine Maker.
Yes, thank you very much, and welcome to our stall at IMTEX 2022 Forming Show.
Thank you very much.
Yes.
And while I was coming here before the show starts, I was just looking at some of the products which are metal 3D printed product that Rafael model as well as it's amazing.
Okay, thank you. So we are actually in 3D printing, and we have the largest amount of experience in 3D printing field. So definitely you can see a lot of things which you will not see anywhere else. And our forte in SRT is our know-how about the technologies and our long-standing experience in this technology.
I have seen that you have a wide range of additive manufacturing solutions, be it metal, be it different materials, and you have 19 companies you are representing in India. Can you just share your brief journey?
Yeah, actually we started in 2007, and when we started, actually we were working with 3D systems, and 3D system is one of the pioneer in 3D printing. They started with the SLA technology, then they have SLS for plastic, and then direct metal printing, multi-jet printing. So I am very proud that we work with the top 3D printing player in the world, and who has the maximum number of technology under their umbrella, and they are leading in all those technologies. So there is no other 3D printing company who has topping in all the fields. So we are actually working with them for the last 15 years, and before that, me and my partner, we both were working for these machines for almost 10 years. So we have total close to 25 years of experience both put together, and that's what separates us out from the other companies.
Yeah, because if you see in metal forming earlier, we used to see more about laser cutting, presses, punching machines and all those things. Today, I think even we have seen in this IMTEX, a lot of additive manufacturing solutions can be seen.
Yes.
But that is 2022. You are talking about 2007. So
yeah, we actually started in 1997.
Oh,
so 1997 is what we started this journey, almost for 10 years, and that is the time when the 3D printing was getting launched in India, and we worked with SLA technology to start with, and those days it was called as rapid prototyping. Now it is called it's called 3D printing, and now it's called additive manufacturing, because people have realized that you are able to get you are able to manufacture components layer by layer. So they are now realized that you can manufacture components. So that's why it's called additive manufacturing. So we have seen the whole. We are fortunate that we have seen the whole journey from the concept stage of rapid prototyping up to the now additive manufacturing.
You're having a wide range of machines displayed here, and some of the components printed. Can you please take us through?
I would like to show you one of the major technology what we are launching at this show is SLA 750. That's the world's first synchronous dual laser SLA printer.
Okay.
So this is the same large frame SLA printer which was Pro X800 before, but it was with the single laser. So this is the machine which comes with dual laser, and it's simultaneously printing part with two lasers and one machine. So this is the commitment of 3D systems to move this technology to production. And when you want to do production, then you need to have multi-laser, and you need to have usable materials. So this is some of the materials what we are launching Acura AMX Rigid Black. This is the first time in India we have this material in our tech center, in our customer innovation center in Mumbai. This actually mimics the initial molded plastic parts, and this is with dual laser system. That's going to be one of the game changer in the market now. So people were only using SLA machine for making prototypes or master pattern. With this material and with this dual laser speed, we will be able to use this technology for production. So short batch production. So you can see it's 24% elongation at break and 64% SGT. We are going very close to injection molded properties.
So, and which are the applications for this batch production? If you see that, what will be the major product?
See, it's going to be a lot of enclosures, a lot of automotive parts, and in rapid prototyping, in 3D printing, people are making master patterns using SLA. Then we are making vacuum casting silicon mold. From silicon mold, they are taking the multiple parts out by vacuum cast. That's a manual process. So this material and this SLA 750, as well as Figure 4 standalone, both these machines are replacing actually the vacuum casting process. So when you want to do multiple pieces in end use like properties, this is the technology that can be used. So definitely for multiple pieces, you can do differently use this.
We have also seen some of the models which is print metal, and this is metal 3D printed, Raphael model. So can you just in which printer it is printed?
This is done again with 3D Systems game-changing technology DMP Flex 350, and we are very proud to have this first machine in India in our customer innovation center. We opened in 2019, and the unique part of this technology is that it's first of all a production-based machine, so it is actually designed for production. So you can actually log all the data, you can log all the parameters like a normal machine tool, and you can record all the data anytime it's required. And also the whole 3D printing, I mean the metal printing happens under the vacuum. So there is only 2% or 2% oxygen content inside the machine. We can also build parts almost without support. So you can see this aircraft is built. You can see this design. So no other technology can print this part with a nose, a point start with a very, very thin wall. It's just impossible. And that is only possible because of the unique features what we have. We have a recoater blade which is silicon. So basically we are able to do very thin walls with very minimum supports. That's the unique thing about this metal. And that's why we are able to do so sharp features. And because it is under vacuum, the metallurgy of this geometry is completely unmatched. There is no oxidation of the powder, there is no oxidation of the fumes. So it's completely under vacuum, under inert environment.
Now this model, whatever we are seeing here, so these are all small miniature this thing, but we can print the same big.
No, why I built this part? This is basically a V8 cylinder block.
Yeah.
This is done in titanium. This is a titanium material. So I told my application people to build a very complex part, and this is to stand apart from the competition. Competition can't do this part. So when people were using competitive technologies, when they have a look at this part, they realize that yes, this is something is unique, and that's what we always talk. That we don't want to show the machine, we want to show the part. And with the kind of patented technology we have with the soft recorder under vacuum and under a very special optics laser used on the technology, we are able to do such thin walls almost without supports. So
this is printed at, you told, DMP Flex 350.
Yes.
Now this can be, this bigger cylindrical block can also be printed there, right?
Yes. At present on this machine, on this particular model, we can do 275 millimeter by 275 by 400 millimeter. And we have a bigger machine than this called DMP 500, where we can do 500 by 500 by 500 millimeter. So yes, we can do, and a lot of people are doing. This is, you can see this is a cylinder head component of automotive part. So people are using it for R&D and it's for development.
Sir, apart from this, which are the other products?
Another technology what I would like to mention about is the Figure 4.
Okay.
So Figure 4 is something which is already established in the market for the last 2-3 years. But now this technology is taking off. So unique the thing about this technology, this worked on a projector, but this is a continuous membrane-based continuous development machine. So it's non-contact. It's a non-contact. It doesn't contact the film. The part doesn't touch the film. So we are able to do very fast part building between 50 millimeter to 100 millimeter per hour in Z-axis the build speed. And the beauty of this machine is it has got almost 30 different materials which you can use on this technology.
Okay.
And starting from PP, ABS slide, high temperature, 150 degrees, 300 degrees. Then we can also do white, gray, black. So you can see this particular, just a minute. So you can see this particular geometry is built. You can see there are almost 4 into 3, 12 parts are done in almost 4 hours. And if you look at the quality of the part, is directly, the quality is same like directly coming out of the injection molding machine. And that is what is people for the limited part production, people are preferring the figure 4.
Which is the material used in this?
This is again more than machine, the material becomes famous. This is Pro Black 10.
Okay.
So everybody in the market knows Pro Black 10. They may not know the machine name.
But that is printed in this.
In this machine, yes.
And it's a contactless machine.
Yeah, it's a contactless because the part is not touching the film. Generally, in a normal DLP machine, it touches the film, then it has to be, you have to remove that. There is a peeling off force which damages sometimes the geometry. But because it's non-contact type, so you are able to print parts very fast speed.
And you're telling 22 materials you can use?
Yes, almost 30.
30 materials,
30.
not metal.
So this machine, all plastic.
All plastic.
All plastic.
Okay.
And here we are able to do, we have 3 models in this. One for engineering, other one is for dental, and other one is for jewelry. So dental has a different materials which are biocompatible and all, and for especially for dental application. Then we have engineering, there's a standalone, and we have figure 4 standalone, figure 4 modular. So you can have multiple machines connected to one controller for production. So in future, we have already installed this machine in most of the tool rooms. Also, we have installed these machines in many of the service bureaus. And in the service bureaus, they are printing parts every day.
So manufactured by 3D systems.
It's manufactured by 3D systems, and the whole software, the materials, and the machine is all 3D systems R&D. And you will be surprised to know that Chuck Hull, who is the originator of 3D printing, the father of 3D printing, he was the main person when this machine was developed.
Oh,
so he is the brain behind this technology. And figure 4 has really changed. Although people call it a normal DLP machine, but it's not a DLP machine because that's why it is different, and that's why it has done a lot of things different which other DLP could not do. So there are a lot of DLP manufacturers in the market, they couldn't get anything close to this. So that is something you can see the part quality. We have grey color part, we have black color part, white color parts.
All printed in
figure 4, and you can see this rigid grey. So they are injection molded like properties, and that's going to change.
So this is also for rapid prototyping or the product development phase, or this also can be used in production.
Also for production.
So for example, I am seeing that this is that particular model where people are using for this temperature.
Exactly. So it can be used for prototyping, it can be used for shortcut production, or it can be used for production also. Why? Because the materials what is being developed, these are not normal SLA materials. These are special materials which are actually proven for 3 to 5 years of life. So the properties of the materials are going to be constant for next 2 to 5 years. So that was not possible on a conventional SLA machine. On a conventional SLA machine, after 1 or 2 months, the part become very stiff, very rigid, and become very brittle. So it's not like this. So even if you touch the part, you can get a feeling it's a plastic-like part. You don't get a feeling that it's a prototype part. So that's the advantage.
What is going to be the cost factor, for batch production when we are talking about? So for my understanding, I am from the media, I print. So there is two kind of
cost is always relative. Why I say relative? Because if somebody wants 12 parts in 4 hours, what is the other technology?
Yeah.
Suppose you want to do injection molding like part, you need to make a mold.
Yes.
What's the cost for the mold? What is the time? What is the lead time in the tool room? Then you have to load it on the injection molding machine. So it's minimum 2 to 3 weeks. Even if you take the best of the tool room available, minimum 2 to 3 weeks. So here in 4 hours you get a plastic injection molded like parts. So I don't think anywhere this is possible. So coming back to the material cost, is around 20 to 25,000 rupees a kilo. So I can make these parts maybe around a 5-10 gram part, maybe around 200 rupees, 300 rupees.
And it stays, as you told, it is reliable, it is rigid,
it is robust. You can put drill inserts into it, everything you can do it. Everything you can do it. Yeah. In fact, you have that stand which you are holding that phone, your camera. I can make the whole stand, a new stand, within hours on the figure 4. And it will work, it will function like that. So
And
another thing, what we have launching here,
yeah,
it is from BCN 3D.
yeah.
That's from Spain. This is the first time we are bringing this to India. This is the FDM desktop professional 3D printer, and here it's a unique company which initially launched. They are the originator and inventor of the IDEX technology. So IDEX is basically you can use two independent extruders simultaneously run and building two separate parts. It can be from same material, it can be from different material, and you can do mirror. This is now going in mirror mode, but you can also do a copy mode. So you can do multiple parts at a time, and we can use PP like ABS like PLA, tough PLA, nylon. You can use glass filled nylons. You can use also carbon fiber mix filaments. Also, we can use metal filaments. So this is very unique. It comes with a smart cabinet. You can store your
Materials.
the materials, the spools here. It's heated, so there is humidity contained, controlled, and directly from the spool, it can take the material. So it will be completely closed environment system. So this is something unique, and biggest selling point is it's the largest build volume. It's 400 millimeter by 300 millimeter by 420 millimeter.
So big parts you can print in
Yeah,
this.
very large part you can print, and it's a production. You can use it on a shop floor. So you
these
can
are
see, you can see some of the complex parts. You can see some of the complex gears we have built. Very very fine detail parts we are able to build. You can see some of the features we have done with the
Texture?
texturing.
Yeah,
This
yeah.
texturing is done.
The texture is done after the printing is done,
No,
or
the texture was done in the file,
okay.
and the printer printed it.
Oh,
Yeah,
okay, okay.
you
So
can see the assembly is being built, so we can do this.
everything is printed in this
Yeah, all assembled together. Yes,
Epilson
yes.
W50.
Epsilon.
It's from
Epsilon
Spain.
W50 from Spain.
Uh-huh.
It's a very reliable and very good technology. Many of the multinationals in Europe they use this.
Mhm.
This first time is coming to India.
Okay. So it can print identical strong functional parts.
Yes, you can see this. You
Yeah,
can see this
yeah.
part. So these are the actually mirror,
Mhm.
left and right mirror holder of the car,
Mhm.
and we are able to print these parts
Okay.
with minimum support. So that's a really amazing technology.
So people who are coming at this exhibition at IMTEX can witness all these products, which is basically world-class products imported from Spain and from other
USA, yeah.
USA 3D systems.
Yes.
And you also have other two
Yeah, we have
machines.
Formlabs also.
Uh-huh.
Formlab is a desktop 3D printer.
Mhm.
It's working on a desktop SLA.
Okay.
So it comes in two sizes. Is Formlab 3 and Formlab 3L.
Okay.
So 3L is around 300 millimeter build platform size. Here you can put a cartridge. The material is falling in here, and there is a laser which cures, and it's completely closed loop system. And we can make very good quality part. And the price of the machine is around 12 to 13 lakhs. So you get SLA quality at 12 to 13 lakhs. So Formlab is very good in doing desktop printing, and they also launch. We are also launching this now. Fuse. You can see this part. This SLS desktop SLS system. So you can get this type of resolution. This type of resolution you can get on the SLA machine, on the SLS machine Fuse from the Formlab, and this is the first time we are launching it here also. So this will be now we will be getting this machine in our facility next month. You can see this part, this SLS nylon part.
So all this able to be the screwing, everything is printed.
Yeah, everything is printed. Everything is printed, and it's a nylon, so it's a very very strong. It will not break. It's like a molded like part. So this is available in desktop facility now. So that's really the Formlab is something what we are bringing is a very good desktop printing technology solutions.
And it is very cost effective.
Yes, very very cost effective.
You told
Yes.
13 to 15
Exactly.
lakhs.
Exactly.
People can start a business today.
Yes,
And
exactly.
engineering company.
A lot of people, a lot of service providers, small startups, they're starting their business with Formlabs,
Okay.
and then they're migrating to the bigger SLM machines.
Bigger machines.
Yeah.
So how is the response you are getting in IMTEX? Like
Yeah, yesterday was little first day being a first day was less, but today I think we are continuously, and my voice also is completely gone. So we are talking since morning, and we are getting continuous inquiries, and we are really overwhelmed by the support and from the industry, and we hope next 4 5 days also goes very good. in the coming years.
So you have this machine. Also, you have another machine.
This is from 3D system.
3D
This
system.
multi-jet.
Uh-huh.
This is our you can say our bread and butter product today.
Okay.
So this is 2500 has done really wonderful job all over the world. And this you can say this is the maximum selling product from 3D systems today in numbers. And there is a big queue, and they are almost 500 machines in the backlog.
500 machines
500
backlog.
They are not able to produce. There are a lot of supply chain issues and all. So there is so much of backlog. So this is being sold in jewelry. It's being sold wax. We have a high resolution. So high resolution wax parts we can make for jewelry. So we have close to 250 machines already in India.
In India.
Yeah, and we almost are every month closing 10 to 15 machines. So this is a production machine for wax pattern for jewelry.
For jewelry.
And this has changed the complete jewelry market. So take the all big name they use this name. You take name of Tanish, you take name of your Tanvi, or take name of Emerald, or not the Emerald, the other companies. They all using Intergold, Gold Star. They all use these wax printers. Very very wide.
What is the cost of this machine?
This is around $55,000.
Okay.
Yeah. So roughly around 45 lakhs.
45 lakhs.
And this run 24 hours. This model was launched around 4 to 5 years back, and since then this has been doing really wonders in the market.
Okay. So I think 3D systems is having a wide range of
Yes, exactly.
additive. They themselves have different parts.
Yes.
You can get it printed.
Yes.
Okay.
So 3D system has got almost 7 to 8 print engines. We call print engines. So multi-jet is one of that. It's a print engine. Figure 4 DLP is one of the print engine. SLA, SLS. Then we have metal print DMP, that metal printing. Then we have also bioprinter from Alevi. Then we also have a fuse deposition with a pellet from there's a company called Titan Robotics they acquired. So they have also from Peak. They have Kumovi's company, that's FDM printer with Peak. So the beauty of 3D system is, although they might have acquired some of these manufacturing technologies, they have integrated so well, and they have put all their know-how, software and everything so well that they are really able to do a very good job afterwards. So most of the people, they don't know this technology, then it becomes very, very difficult for them to digest the technology. But 3D systems always acquires the technology before they have a full understanding of the technology, and then they'll go ahead with acquiring this. So that's why they have the widest range of applications, and being the oldest in the market, they know what market needs. So they are in a proper way, they are in a proper position to position the systems in the market with the correct technology.
So it is a lot of products, 3D printing machines available here,
Yeah.
and a lot of printed parts, which itself you told that is what you need to show, not the machine.
Yeah.
So a wonderful globe printed in metal.
Yeah.
I think I'm sure
So
it is.
actually, this is our unique part. So this is done in aluminum.
Oh.
This is the globe, and this what we have done is all lattice structure in different lattice design. So this is done by our metal application engineer in Mumbai in our facility, and this whole part was built as it is without any supports. So only support was at the bottom, which we just cut off, and we take this globe out. So this is now no other metal printer can do this kind of job.
And this is printed in which machine?
This is done in DMP 350.
DMP 350.
And this is unique thing what we have built. And this is another what we have done is like a medal, like a trophy. You see, this is again done with a minimum wall thickness as well as with a very fine lattice structure. So my colleague maybe here, I think he's not here. I could have introduced you, but I can introduce you. So he has built this part.
Acha, I was there at. Acha, he only no.
No, we will. I will metal expert.
Okay, I was there at your technology center.
He is Lokesh.
Lokesh, yeah.
So he and his team has built all these metal parts. He's our lead metal application person, and he is basically metallurgist. So he has the kind of experience, and I always give them a free hand, and that's the part they build. So that's unique thing. So as I told in Shree Rapid, what is important is the know-how, not the machine. Machine anybody can supply you, but how to build the best quality part, how to build the different parameters, that is what is our know-how, and that is why we have our own customer innovation center, and people work in the innovation center along with the principals, along with the manufacturers, and we develop parts.
I had the opportunity to visit your technology center. I
Yes.
was able to meet Lokesh that day,
Yes.
and I was amazed to see that such a big DMP 350 only. I think
Yes,
it was
yes,
there, and
yes.
it was such a big machine, and I loved it actually.
Yes,
So thanks, Lokesh. I'm sure you are having a wonderful time here explaining how it is printed, but I'm sure you are missing your
Machine.
DMP Plex 350 here.
Yeah. Sure. Sure.
All- Yeah, please visit anyway. Please visit the Shree Rapid System Technologies stall at IMTEX. They are at opening of Hall 3A. And if you are not able to visit here, definitely you can go and catch up location, find out what DMP 350 can do wonders for your manufacturing, especially as you told for the production. You can have
We are printing for almost last 1 year titanium implants, and those are going into the bodies of the people. So that is we are doing for some implant companies, and we do very thin wall titanium customized special implants, especially after the cases of COVID with the black fungus cases. A lot of people have lost the sarcoma bones, and we are doing those reconstruction. So a lot of we are building those parts on our machine. So now I would like to introduce you to my colleague Ajay. He will take you to the other part of our systems. And Ajay is my colleague. And please explain to them about all the technologies what we have other than 3D printing. So hand it over to you. Thank you.
Thank you very much, Nitin Saab, for your time. And I wish you all the very best. Thanks for spending your time. All the best. Hello, Ajay Saab. Hope you're doing great.
Yep.
We
With the crowd today.
Yeah, from the
a good
morning.
crowd today.
Yeah, very good crowd. And I seen your video yesterday. It was great, and you were. I don't have any part to give. Yesterday there was an offer from Ajay sir that if you are able to bring a part, he will scan and give me that.
True. Yeah. We have absolutely no heights about it. That we are ready to show parts which they bring here. And today also a few customers came to us and wanted to show us the parts, and we ran a scan and gave it to them, part of it there.
Okay.
We don't give the whole part, but we do a part of the part there and give it to them there. So
See,
that they understand the technology.
Why this bike is here?
So the bike is being scanned. We just finished scanning of this bike. It was given to us by a customer, and he wanted to replicate this part. And so the intention was that he would replicate the complete body, make a copy of it, and make some modification and have a new one developed. So we scanned the data there, and we have a replica of it exactly with us here. So it was used using the scanner here, which is here. This is a hand scanner, which is from GOM, Zeiss, a Zeiss Group company. It's called T-Scan Hawk. And this was used to run all over the face here and completely covered in about 1 hour's time.
1 hour.
Yes.
You're able to scan the
entire thing.
So
and you have the data there within that. All you need to do is make a model file out of it, and it's ready.
But the CAD file is ready also.
The CAD file, yes. So it just needs a little bit of final finish touches which are there, and once it's done, it's ready to be copied.
So basically, this is we can say you are doing the reverse engineering here.
That's right.
So
It's not just reverse engineering; it also does measurement here.
Okay.
So once the data is ready, you can do a measurement also. You can measure a diameter here because it's already been scanned. We can just touch the software and touch the positions, and you can get the distances, the cylindricity, the concentricities, everything in a geometric format report required for a quality control department. So you can have all the dimensions which also are captured while it is being scanned. That's the beauty of this equipment.
Shree Rapid, SRT is famous for additive manufacturing. You see, you have wide range of additive manufacturing machines. Different materials can be printed. What is this machine tool division is all about?
So about 2.5, 3 years back, the vision was that while the going gets good, let's add some more lines which are the front end and the back end of 3D printing. So we devised the process wherein we wanted not just the focus on 3D printing, but we wanted the front end and the back end. What it means is, if somebody wants to do a 3D printed part, he has to have the design. That means he has to define a design how to do it. So we brought a software and a hardware called GOM, Zeiss, which can scan an unknown part and completely digitize the data. This data will then be taken by the 3D printer and again reprinted with modifications or changes done there. That's the part of 3D printing. Next stage comes is once the part is 3D printed, then you take over from there and once again measure it. So the part that has been 3D printed can actually be measured again on the same equipment, or we have additionally another line from Zeiss, which once again has equipments for roughness testing, for roundness testings, for non-contact measurements and contact measurements called 3D coordinate measuring machine. And we also have an X-ray and non-contact X-ray from Zeiss, which we can just measure immediately within few seconds the parts there. So this was the next stage of Shree Rapid Technologies to go up the value chain. 3D printing is fine, but you need to go to the next stage and support the customer in these days when a lot of technology transfer is happening to India. People are not getting the CAD files from the original manufacturers. So what they do is they bring the part bring it here, copy it, digitize it, 3D print it, then they bring it back again and say, we want to measure it. We measure it again on the same equipment or on the Zeiss equipments and give them the final data. That's what we call as a value chain addition in our scope. So this becomes a strategy of our division now that we offer new technologies to them. So where Nitin left behind on 3D printing of parts which were smaller in size, I consider small as 500, we took it to a next level. We brought a company from Australia called Titomic. That company is into manufacturing of 3D printing parts of 9 meters size maximum. You can have a 9 meters 4-ton part built from powder to a shape, a profile by 3D printing it. And within a matter of 14-15 hours, you can print 9 tons of material. That's the speed of this metal printer. In metal, in aluminium, in steel, in titanium, whatever you want, these specific materials can be done and developed. So we brought them to the next level here. We want to give to the customers in India a process which otherwise takes 6 months to develop, from tooling stage to finishing stage, can be done within 3 days of 3D printing, and post-processing like heat treatment can be done in 3 days, sir. A 9 meter long part, up to 9 meter long part can be done there. So that was the addition that we added in our portfolio. Beyond that, you saw that there were wax printers in there were metal printers there. We brought in a new technology called 3D Ceram, which is ceramic printers, which means we brought in a technology from France for printing of ceramic parts in defense applications, in dental applications. I have my colleague from France, Mr. Max, who will give you a little bit of an insight on 3D printing of ceramic parts and some of the parts that we have brought here to show on the machines that are made in their company. And I will hand it over first to Max. Max, take care. Please explain them the technology.
Thank you, Mr. Ajoy, for your time and
I will finish here. I will take over and show you some more.
definitely. So I will finish with Max and I will come back. Hi, Max.
Hi.
How you are finding India?
Good. So, it is not my first time in India. It is my second time, but each time it is a great pleasure to be there, to be in India with all of kind people, the support of Shree Rapid Technology. So very glad to be there today. And it is my first time at the exhibition IMTEX. Thanks to all the support also of Shree Rapid. So very happy to be there today with you.
Thank you. Thank you very much for joining with us. And I wish you a great time here.
Thanks.
And a lot of inquiry about 3D Ceram. Now, what is this machine all about, which you are bringing from France to India?
Yes, exactly. So as I just said, it is a French-based company which was created in 2001, so roughly 20 years ago. And our activity and business model is to provide solutions for the 3D printing of technical ceramic parts. So we developed stereolithography technology in order to print this kind of parts that I will show you after. Stereolithography means that we use a slurry. Slurry is a mix of ceramic powder and photosensitive resins. And then the part will be printed layer by layer to the bottom to the top, thanks to UV laser based on the top of the printer. So our technology that we developed specifically for technical ceramic parts is a UV curing process. So you have to keep in mind that after the printing, as it is a curing process, we need to do 2 thermal treatments. First one, the debinding step to burn, to remove the resins, and then the sintering step to close the porosity and to densify the part. I would say that we are what we can call a process provider, which means that we do not only provide the printers, but we provide all the items of the printing line. The software, specifically developed for the printing of technical ceramic parts, the printer, and regarding the printer, we develop a large range of printers, from lab to fab, to the small one to the big one. For instance, the C100 Easy Lab, 100 because the size of the printing platform is 100 mm per 100 per 150 for the Z-axis, and the bigger one, the 3600 Ultimate, with a printing platform of 600 per 600 per 300 mm. This printer is the bigger printer for technical ceramic available on all the market. Then we also provide the cleaning station, the debinding station, and the sintering station. So all the items of the printing line to allow our customer, our users, to use as quickly and as efficiently as possible the printing line. Then I want to say a few words about some different and the main application you can use ceramic 3D printing. So it is mainly space, implants for healthcare, and foundry cores for investment casting. First of all, healthcare, implants. As you might know, at this time, most of the implants, the 3D printed implants, are made with titanium. But we have more and more requests for printed ceramic implants due to the biocompatibility property of the ceramic and the zirconia implants. For example, we can print spinel cages. So obviously, this design is only feasible with 3D printing, but moreover, the ceramic used for this kind of implants, HAP, hydroxyapatite, have a chemical composition very close to the bone. The chemical composition of the bone is quite the same than this part. So which means that few weeks after the operation, the real bone will create some links, some physical links into the hole. So you cannot have any risk of rejection after the operation. Another example of parts that I really want to show you, it is zirconia implants, zirconia screws. Same things. At this time, most of the implants are made with titanium. But with titanium, you can have some corrosion after a few weeks, few months, few years. With zirconia, it is impossible to have this kind of effect. This is why more and more of the hospital prefer to use zirconia implants. And only 3D printing can allow you to obtain this quality of parts. This it is for all the healthcare implants. Then space. Space, and that we call a new space, use more and more ceramic 3D printing for three kinds of parts. Antenna for telecommunication, structural parts, and optical parts. Here you have an alumina optical part, a mirror, print on our medium size printer. So why they want to use a 3D printing? Because thanks to additive manufacturing process, you can shape some new design that you cannot do with any other process. And you can decrease the weight of the part. And in the field of space, if you can decrease the weight of the part, you can save some fuel. And if you can save some fuel, you can save some cost, which is a key point. And the last application we use more and more ceramic 3D printing is foundry cores for investment casting, for turbine blade. Same things. Why do they want to use 3D printing? Because at this time, the ceramic parts are already made by conventional process. But in order to do such complex design, they have to use CIM, ceramic injection molding. And they have to do 3-4 easy design of parts. And with 3D printing, you can do the same design in one piece. So obviously, you can decrease the waste and decrease the lead time in order to produce such parts.
It's a excellent technology, and I think with this, there are a lot of benefit to the healthcare industry.
Yes.
And I wish you all the very best on this.
Thank
you. Have a great time at IMTEX.
Thank you, Ari.
Yeah.
Goodbye.
Yeah. Thank you.
Thanks.
So it
Thank
is
you very much.
Yeah, it is a wonderful technology.
It's what was 3D printing at nascent stage in the early days for other parts. Now this is the new in thing. You will see ceramics being a big addition in the whole thing. Additive manufacturing space.
And lots of applications which can help you.
Absolutely, as we said, space, the largest one, dental, medical, health, all these are basic things there. Engineering will go on. We'll have a lot of work in engineering to do in defense areas. So we expect one of the largest benefits of these coming up in the new stages. India is moving a lot faster in engineering. So we will see a lot of benefits happening from this product line as well. We are looking forward to it.
Yes. And do you have anything else?
Yes, so we also represent Zeiss, as
Yeah.
I said. Zeiss has a product level which is a 150 years old company today. We work with them very closely on coordinate measuring machines for products on the shop floor manufacturing and measurements, as well as in standard room technologies, which are accuracies of 0.5 microns. Can you imagine 0.5 microns is what they measure here on these machines here. So you can see a deviation of that 1 or 2 microns now being able to measure on such machines. The lowest one, which is showing down there, called the MMZ, is used for very, very large parts for aerospace industries to be measured there. So these are technologies which have multiple probe heads on the same machine. You can do a non-contact measurement, you can do scanning, you can do reverse engineering as well as measurement using the Zeiss mass technology. This is one of the newly launched product line.
We were there
in
live.
It was launched yesterday in India the first time with this new technology. So we work very closely with Zeiss India in Bangalore and have a very great support line from them as well. So this is one of the stars in our portfolio that we have now as well for the last 2 years. So this is the chain of front end and back end that we are putting together to showcase this technology to the entire engineering field here.
So, starting from additive manufacturing
Yes.
and taking the value chain ahead,
Yes.
you have a lot of solutions when it comes to the, finding the quality, metrology, and I'm sure that each and every visitor who comes and visit your stall is going to take some solution
Of course.
for their manufacturing process.
Absolutely. You cannot walk away from this place if you're seriously buying something for your new lines, for new technologies. Not only just that, you miss something behind you. This is the electron beam welding machines in India, which is used for space application.
Okay.
You can weld two parts in vacuum together without any addition of material. The same material is melted and you can produce the part for space application. This is a fuel tank for space application, which is joined together in titanium, which is the most difficult material to weld together. So we have principles and products which are cutting edge technologies here and being used by world-class companies here. So we expect that whoever is serious in business will walk by, come on us and discuss with us.
This is from TechMeta, France.
Yeah, this is from TechMeta in France.
So, the 19 companies what you have,
Yes.
that is in additive manufacturing also include this, or this is a different vertical as
This
such?
is a complete vertical.
So 19 companies you represented in the additive manufacturing.
That's right.
Apart from that, you have this machine tool division,
Yes.
where you are having a lot of solutions when it comes to metrology. Now, when you come into welding and lots of other
And
solutions.
straightening. Don't forget there the MAE is a straightening machine which is used to straighten parts which have to be fitted in automotive sectors, in defense sectors. You can straighten these on the straightening machines from MAE in Germany. So we are adding lines which are required by the defense organizations, by the automotive companies for their new product lines, including the EVs here today. So we feel very happy that these are products coming on our shelf, our shelf to work around there. That's what we think.
Thank you very much, Ajay ji, for
Yes, sir.
sharing us all these information about the stall at Shree Rapid Technologies.
Welcome, sir.
So till now we were knowing that it is about Shree Rapid Technologies, all about additive manufacturing.
Yes, sir.
Today you helped us to know that
Pleasure, sir.
it is just
So people will understand. People have been now finding a new product line beyond that. So far we were constrained in a small section. Now we are increasing our portfolio for people to come and see us wherever there were any limitations.
So thank you very much, and we wish you all the very best for next 4 days.
Thank you, sir.
I think that you had a great time today, and
Yes.
we wish the same kind of rush
To keep coming
to
for the
keep
next 4
coming.
days.
Yeah, please visit Shree Rapid Technologies. There are a lot of technologies you can witness here, which will help your manufacturing process. Thank you for joining with us in this real-time broadcast with Machine Maker. Thank you.
Thank you, sir. Yes.